So today we have this interesting integration question. The question says that we have to integrate e to the power x multiplied by x to the power 4 plus 2 divided by 1 plus x squared to the power 5 by 2. This problem is enough to tell you how logically you have to think while solving an integration. So let us see how can we solve this. So first step is that I will just consider my integration as I. Yes, that's our first step, that integration should be equals to I. Yes, now let us move further. Now what I can observe is that x to the power 4 plus 2, everything in this, like over here it's like 1 plus x squared to the 5 by 2 e to the power x is there. This thing is looking very normal type, so I will just convert it in something else. So what I will do is that x4 to the power plus 2 is looking like x square the whole square. X4 becomes like this way. Now I will write 2 times x square into 1. Now I will add 1. Now you can see x4 plus 2 I have written like this way, but it's not true, as I have added 2 times x square plus 1. So I have to add and subtract something else also, so that they both are exactly same. We have just done a little modification. So plus 2 we need, and I have already added plus 1, so I will just add plus 1. So plus 2 has been formed over here. Now I can see 2 times x square is an extra thing, so it's in addition, so I will just subtract minus 2 times x square. So you can see these things were added and these things are just subtracted. This both were additional things, and this I have to just subtract. So addition and subtraction of 1 plus 2 times x square in this question. Now look over here, from here to here, what I can observe, it's the algebraic identity x square plus 1 the whole square. Observe over here, x square the whole square plus 2 times ab, that is x square 1 plus 1 the whole square, that is 1. And this thing x as it is, that is plus 1 minus 2 times x square. So x4 plus 2 can be written as 1 plus x square, or else x square plus 1 both are same, the whole square plus 1 minus 2 times x square. So instead of that x4 plus 2 I will write this thing. So let us do that, not x4, x to the power 4 I mean. So let us do that. So integration of e to the power x as it is. Now x to the power 4 plus 2 I have written as 1 plus x square the whole square plus 1 minus of 2 times x square divided by 1 plus x square to the power 5 by 2 and the dx. Yes. Now I will just separate the denominator with this square one time, and the other separated it 1 minus 2 times x square. So integration of e to the power x as it is. Now 1 plus x square the whole square divided by 1 plus x square 5 by 2 and plus 1 minus 2 times x square upon 1 plus x square 5 by 2. As you can see, I have just separated the denominator with this 1 plus x square the whole square, and then after 1 minus 2 times x square. Now here I can observe a power cancellation can occur, because 1 plus x square 1 plus x square is there. So let us have the exponential rule, that is a to the power m upon a to the power n. So it is equals to 1 upon a to the power n minus m, or else it is equals to a to the power m minus n. It can be either this or either this. So I will just convert this in this form, that is the power of the numerator will subtract the denominator. So let us do that over here. So integration of e to the power x as it is. Now it will turn out to be 5 upon 2 is there, and I have to subtract 2. So 5 upon 2 minus 2, that is 5 minus 4 upon 2, that is 1 by 2, that's half. So it will form 1 plus x square and half. The exponential rule, that the power has been subtracted, and that is equals to, not equals to, plus, and that has been added to 1 minus 2 times x square upon 1 plus x square to the power 5 by 2. Now till now you have just think that yes, x to the power 4 plus 2 was modified like a very different way, and we have reached this. But now the step will just amaze you. Yes, this step is the main step of this integration, or else we can say the master step. Let me first write the steps. So integration of e to the power x 1 upon 1 plus x square 1 by 2, add x upon 1 plus x square to the power 3 by 2, and subtract the same thing, that is x upon 1 plus x square to the power 3 by 2, and add the last thing, that is 1 minus 2 times x square, that is 1 minus 2 times x square upon 1 plus x square and to the power 5 by 2 and dx. Yes, as you can see, this thing, that is plus of x upon 1 plus x square 3 by 2 was added and subtracted, and that was the master step. because in any of the equation you can add and subtract anything, it makes no changes. But what to add and what to subtract has to be very crucial. Yes, so let us see how can we now further simplify this. Before that, let us revise the rule that integration of e to the power x multiplied by f of x plus the same derivative of f of x, that is f dash dx is there. So its value is equals to e to the power x multiplied by the function and plus the constant c. Yes, if any integration of this type, that is ex bracket f of x plus the derivative of the same of f(x), then the integration is equals to e to the power x, whatever the f of x is there in multiplication, and plus the constant c. This is the rule of integration. Its derivative is also very means its derivation is very also simple, but we will not discuss that. It's the rule. So according to this rule, I will just simplify over here. So ex is multiplied with everything in this bracket, so just I will do a thing that I will just separate it like this way. I will do it change the color so everything is clear. I will write integration of e to the power x 1 upon 1 plus x square to the power 1 by 2 plus x upon 1 plus x square to the power 3 by 2, and then I will write minus e to the power x, or else plus, let it be minus only, x upon 1 plus x square to the power 3 by 2, and over here it would be negative 1 plus 2 times 1 minus 2 times x square upon 1 plus x square to the power 5 by 2 and dx. Yes, now both of them add together over here. Now look over here, ex was there and this thing was there. These 4 terms were there. So I've just opened ex with these first 2 terms together, then this negative sign, and open with this 2. X was negative and this was positive. So when I took negative sign common out, so it becomes positive, the other become the negative. Yes, now I will use this rule to simplify this equation. Yes, now is that we have added and subtracted x upon this thing, so I will keep the negative one the first and the adding one the second one. It makes no changes. So I will just do that this is my negative and this is my positive. I've changed this sign only, that adding and subtracting, that's the no change over there, but I've just kept the negative first and the positive second one. So according to that, over here it would be negative and the other becomes the positive. So I will take positive e to the power x common out, and so everything is positive in this second bracket. Yes, you can just, I will just explain what I've done. What I've done was, over here before, this was my negative and this was my positive, so there was changes over there. Now I've done this negative and that positive, that was a mistake over there. So in first bracket negative sign as it is, and in the second bracket when I've taken out negative e to the power x common, because this sign was negative, now everything has been positive. So now let us check the derivative. So it is my f of x. Now let us check the derivative, whether it's the f dash x, that is the derivative of f of x, is not. If that becomes f dash of x, so I can use this property directly. So let us do that. So f of x is equals to 1 upon 1 plus x square to the power 1 by 2. Its derivative would be negative of 1 by 2 multiply by 2 times x 1 plus x square to the power 3 by 2. I will not go in deep according to the derivatives because we are doing integration. So you must be knowing derivatives. So this and this cancel out. So what I gain is negative x upon 1 plus x square 3 by 2, and that's the second term, I guess. Yes, negative of this thing is there. That's why when I just first wrote f of x is equals to this, I guessed that its derivative would come in negative, but here I have written positive. That's why I suddenly changed the sign over there. So yes, the derivative of that exists. So integration of this much part, that is the first part, would be equals to e to the power x and multiply with f of x. So that is equals to e to the power x, and the first term was 1, means the first function was 1 plus x square to the power 3 by 2. Yes, 1 plus x squared, not 3 by 2, 1 by 2. The first function we have to take, means the original function which is there. So 1 by 2. This was the value of the first integration. Now let us move to the second bracket and check whether the derivative of this thing, that is my g of x, whether it's equals to this or not, means whether it is g dash x or not. So gx is x upon 1 plus x squared to the power 3 by 2. So it would be equals to 1 upon 1 plus x squared to the power 3 by 2 addition x multiplied by 2 times x multiplied by negative 3 by 2 upon 1 plus x square to the power 5 by 2. This is the derivative of this thing. It's very simple over here. So now 2 and 2 cancelled, and now taking the LCM, so common LCM 1 plus x square to the power 5 by 2. Here the thing would be multiplied, that is 1 plus x square, and here it is x into x square minus 3x square. So that is equals to, I guess, 1 minus 1, that is equals to 1 minus 2 times x square upon 1 plus x square to the power 5 by 2. Let us check whether this was the second one or not. Yes, the second term is exactly equals to g dash, that is the derivative of g of x. So its derivative is present over here, so it is in this form. That's the rule says that integration of e to the power x, a function, plus the derivative of the same function. So it is there in that rule. So according to that, it would turn out to be ex and multiplied by the same function. So the function over here was x upon 1 plus x square the whole cube, so multiplied by x upon 1 plus x square to the power 3 by 2 and plus the constant c, and that's our answer. You can see how ridiculous this problem was. First of all, we have to just do this modification with the term that was x to the power 4 plus 2. Then the main step, we have to add and subtract x upon 1 plus x square to the power 3 by 2. This very external thing we have to add and subtract. Then this thing has been simplified in two parts. This was the first, this was the second, and combining the both will give us the answer, and that was our answer. So if you found this problem interesting, do subscribe to the channel and admit that you are unable to solve this interesting problem by giving a like to the video. Also, I thought that this problem was very nested. If there exists a very simple and very easy method other than this, you can comment below, or else you can DM me on my Instagram. Link is in the description.